Okay, this is a quick little introduction for lab number 6, and this lab usually does need more explanation than some of the previous labs. What we're going to be taking a look at is taking a look at resonance. And anytime you blow on an air cavity, then think about a closed tube. Then what we're going to have is we're going to have a node on the bottom and an antinode at the top. So here I'm going to put a node. Here I'm going to put an antinode. Essentially what's happening is the air is free to move right here. It is not free to move down here, and so it's kind of stuck, thus allowing us a node where nothing moves and an antinode where things are free to move. So what we're going to do is we're going to open up the simulation right here, and this simulation is going to be a closed tube. So you're going to open this guy right over here and click the begin button. And we're going to scan this tube, and I want to activate the grid because I'm going to need that in a little bit. So I hit the scan button, leave it right down here for a little bit, and it's going to scan up. And it's actually going to stop when this thing is going to start to resonate, and you're going to be able to see what the wavelength looks like. Again, there's going to be a node on the closed end and an antinode on the open end because the air is free to move right here. It's not allowed to move right here. So now you can use the grid mark to measure the length of the tube and the frequency, and this will change based on every time you open up the lab. So what you're going to do is you're going to pop back to the lab, record the frequency, and record the resonant length. Now we're interested in figuring out what the wavelength is. And one thing to kind of bear in mind is we had a wave that kind of looked like that. Now what is a wavelength? Well, a wavelength is one full up and one full down. So here's one full up, or there's half of an up and down, and if I were to extend this guy out, this is going to be what one wavelength ought to be. So right over there is my one wavelength, and so kind of what we were looking at was going to be about a quarter of a wavelength. So that was the distance that we measured. That was the resonant length, so 1/4 of a wavelength. In order to go from our resonant length to our wavelength, we're going to go ahead and multiply by 4. Then what we're going to do is we're going to come down here and calculate the speed of sound. And pretty straightforward. We've measured the frequency, we've measured the wavelength, and we're going to say V is equal to wavelength multiplied by frequency. Calculate what the speed of sound is. Then we're going to make the pipe slightly longer and see how that affects the resonant frequency. So what we're going to do is we're going to go back to our simulation. We're going to click on the tube, make it a little bit longer. And we're going to do the same thing. We're going to scan our way through the frequencies, and it's going to hit some resonant length. And we're going to pretty much do the same thing. We're going to record the length, we're going to record the frequency, and calculate the speed of sound. Only this time what we're going to do is we're going to, first thing we're going to do is we're going to go back to the lab, and we're going to record those guys for resonant length 2, frequency 2, and wavelength number 2, so here, here, and here. Calculate the speed of sound again. Please do show your work. And then you're not going to change your length. You're just going to press the scan button again and keep scanning until we hit the next highest frequency. And I've already kind of done this one, so I know that I need to look at a higher frequency. So you could hit this button. It's going to keep on going, but I know that I'm not going to hit it in the 250 range. So you're probably going to need to go up here, hit this little button, and it'll look up a little bit higher. And here we found the next one. And this is the next highest resonant frequency, and you kind of take a look at this, and this is going to not look like a quarter of a wavelength. Remember that one full wavelength is going to be one full up and one full down. And I don't know about you all, but it looks like we have 3/4 of a wavelength right down here. And so what you're going to do is you're going to use the resonant length and that information to figure out what the wavelength is, calculate the frequency and the speed of sound, and then just make some observations, kind of like you did in the speed of sound lab.